Here's example 9 of sum and difference formulas. So we want to evaluate the tangent of the quantity inverse cosine of 4/5 plus inverse sine of root 2 over 2. So kind of a big mess here. We have trig and inverse trig and a sum of two angles in here. So remember, if you take the inverse trig function of some number, technically what you get back is an angle, or you can think of it as an angle anyway. So it's the tangent of one angle plus another angle. So what we're probably going to want to use at some point is the sum formula for tangent here. So tangent of alpha plus beta is tan alpha plus tan beta, all divided by 1 minus tan alpha times tan beta. Okay. So eventually we're going to want to use that. So this guy here is going to be our alpha. Okay. Alpha is the inverse cosine of 4 over 5, and then this guy right here is our beta. Beta. So let's see if we can simplify anything first. So inverse cosine of 4 over 5. 4 over 5 is not really a nice number that is related to anything on the unit circle, so we can't evaluate this directly. But if we look over here, inverse sine of root 2 over 2, that actually is something we can evaluate using the unit circle. So it's just a matter of remembering inverse trig functions, how they work, and remembering the unit circle. So we know that the inverse sine, so actually what we can say right now, right away, is beta, which we just set to be the inverse sine of root 2 over 2, that equals pi over 4. Okay. So that's pi over 4. Okay, so then actually the problem simplifies a little bit. So now it becomes tangent. So now what we want to really evaluate is tangent of inverse cosine of 4 over 5 plus inverse sine of root 2 over 2 we just found out is pi over 4. So that's just some inverse trig and unit circle there. So pi over 4. Okay, so now we're still going to approach this using the sum formula for tangents. Oh, by the way, if you want a copy of this, check the video description. There's a link in there. You can click that link and open up a copy of this if you'd like. Okay, so we're still going to approach this the same way using the sum formula for tangent. So this is alpha, this is still beta. So if we use our sum formula for tangent, then what we're going to have is tangent of alpha on top, which is tangent of inverse cosine of 4/5, and then plus tangent of beta, but we know beta is just pi over 4 now, so that's a little simpler. And then all divided by 1 minus tangent of alpha times the tangent of beta. Okay, so that's what we have there. Now, tangent of beta, tangent of pi over 4 is just 1, so that's nice, but now we have to, separately off to the side, we have to work on this here, tangent of inverse cosine of 4 over 5. So let's come off to the side and do that. So tangent of inverse cosine of 4 over 5. So this is a trig with inverse trig problem, and we've done quite a few things like this before, so we won't go through all the details. There are some earlier videos that talk about all the details, but we'll skip all those here, and just in the interest of saving time. So then the way we have to do this is with reference triangles. So since we're taking the inverse cosine of something positive, okay, inverse cosine is something positive, then what we have to do is set up our reference triangle to be in the first quadrant. Okay, x-axis, y-axis. So here's our reference triangle. So, and remember, inverse cosine of 4 over 5, we were calling that alpha. So inverse cosine of 4 over 5, that is our alpha. That's what we've been calling it since the very beginning up here. Okay, alpha is the inverse cosine of 4 over 5. So here's our angle alpha. Okay, so alpha equals inverse cosine of 4 over 5. Okay, so if we take the cosine of both sides, then what that means is that cosine of alpha equals 4 over 5. Okay, so if we draw our right triangle here in the first quadrant, and again it's in the first quadrant because we're taking the inverse cosine of something positive, so we're in the first quadrant. So if we draw this reference triangle, here's our angle alpha. Cosine of alpha is 4 over 5, which is adjacent over hypotenuse. So if this is 4, that's 5. 3, 4, 5 right triangle. Or you could call this side y, and then just do y squared plus 4 squared equals equals 5 squared, or 25. So then y squared plus 16 equals 25. Subtract 16 for both sides. Y squared equals 9. So then y equals plus or minus 3. Then we take positive 3 because we're in the first quadrant where all the sides are going to be positive. Okay? All right, so anyway. Or if you just remember 3, 4, 5 right triangle, 3, 4, 5 is a Pythagorean triplet. So if this is 4 and the hypotenuse is 5 and the other side has to be 3. So anyway, now what we want is the tangent of alpha, right? So remember, alpha is the inverse cosine of 4 over 5. So, and what we want is tangent of the inverse cosine of 4 over 5. And alpha is inverse cosine of 4 over 5, so really what we want is just tangent of alpha, okay? So what's tangent of alpha? Well, tangent of alpha is opposites over adjacent. So tangent of alpha is 3 over 4. And that's exactly what we want here, okay? So tangent, what we just found out is that tangent of alpha, or in other words, tangent of the inverse cosine of 4 over 5, is 3 over 4, okay? So this whole thing right here is 3 divided by 4. And tangent of pi over 4, we know that that equals 1. Okay. And then same thing down here, tangent of pi over 4 equals 1. And then this right here, tangent of the inverse cosine of 4 over 5, remember that's tangent of alpha, which we just found out is 3 over 4. Okay, okay, so then if we go back to the original problem, so we'll separate that a little bit, go back to the original problem, then this equals 3 over 4, and then plus 1. Is remember tangent of inverse cosine of 4 over 5, we just found out that's 3 over 4 because that's tangent of alpha, and we set up this reference triangle here in the first quadrant. And then plus tangent of pi over 4 is 1, so plus 1. Then on the bottom we have 1 minus from our formula, and then this is 3/4 multiplied by 1. Okay, so a couple different ways we can proceed, but since these are relatively simple fractions, we'll just get common denominators on the top and bottom. So 3/4 plus 4 over 4. Okay, so 1, if we multiply 1 by 4 over 4, then that'll give us a common denominator on top. We'll do the same thing on the bottom. So 3/4 times 1 is just 3/4, so this 1 right here doesn't really do anything, we don't care about it. But this 1 right here we have to multiply by 4 over 4, so we have a common denominator. So 4 over 4 minus 3 over 4. Okay. So then what we have is 3 over 4 plus 4 over 4, that's 7 over 4. And then we're dividing that by 4 over 4 minus 3 over 4 is 1 over 4. Okay. If you divide by 1/4, that's like multiplying by the reciprocal, which is like multiplying by 4. So it's 7 over 4 times 4. Okay. So the 4's cancel, that's great. And then what we're left with is just plain old 7. And that's our answer, 7. Okay. So, kind of crazy, right? So if you look, tangent of the inverse cosine of 4 over 5 plus the inverse sine of root 2 over 2, kind of a big, well, not really terrible mess, but a little more messy than just 7. Anyway, that's our answer, is 7. So this messy expression right here exactly equals 7. So kind of interesting. Anyway, that's example 9 of using sum and difference formulas to evaluate a trig expression.